Hi, welcome to this channel. This is Leetcode 820 short encoding of words. So I'll explain the problem statement over here. So we have given a list of words. From here what we need to return is minimum length of a shortest reference string which satisfies these three conditions. So what is the property of this reference string? So reference string first property is word dot length equal to indices dot length. So here we need to form two things. First one is the reference string, second one is the indices. So I'll just quickly write how it looked like. So for example, here the solution for this one will be, so this is the reference string and indices array will be something like 0, 2 and 5. Okay. So we have to return the what is the length of this reference string. In this case it will be 10. Then first property is word dot length equal to indices length. It means that in this case word dot length is 3, so indices length will also be 3. Next case is the reference string should end with has, and the third condition is all the indices you will provide from there. Let's say in this case you provide 0, so from 0 to next has, what is the word you will getting, that should be present into the word array. Similarly from 2 to has, this will be me, this will also be present over here. Similarly from here to here, this will also be present over here. So you have to provide such reference string in such a way that reference string as well as this indices array in such a way that which will cover all the elements present in the word list. Okay. So and this length, reference length would be minimum. So what we can do is, one simple solution would be concatenate all the words you have. For example, in this case it will be time, has, me, has and bell, right? This will satisfy all the conditions we have, and then you can provide the indices such as, for example, here it will be 0, 1, 2, 3, 4, 5, 6, 7, 8. So you can provide 0, 5 and 8, and this will be the length of reference string which you can return. Okay. So but we need to find the shortest length. So how you can optimize it, because we will be computing whenever you provide an indices, from that index to has we will be finding the subarray. So for example, here to here this is me and this will be also present here. So why can't we can remove me over here? Reason is because if you provide indices as a 2, this can cover this particular word. Okay, so by this example it clearly shows that we somehow find the suffix of a word and see if it is already present in some other word or not. So the problem statement would be, if there is some suffix, right, if there is some word, right, and let's say there is a 2 word, time and me. So me is the suffix of this word. So if you include time in our reference string, then this me is not required. Then the simple solution would be, what we can do, simply just traverse the array, right, and choose one word at a time. Let's say there is a, we have given time, me and bell. What we can choose is pick up the first number, let's say, which is time, and then for all the remaining words check if any of them is the suffix of this word or not. So me is clearly the suffix of this word, so remove it, and then bell is not the suffix, so remove. Now pick the another word remaining from here, which is bell, and now there is no such word which we need to compare the suffix. So let's say there is one word or ll, then if you see ell is already the suffix of this word, so we can remove this. So after doing all these steps, whatever words we are left with, we just concatenate this one, time, has and bell, has. This will be our the reference string, and this will be minimum. The reason being, if there is some suffix, we already removed it, that's why it's a minimal one. What is the time complexity in this case? So for the time complexity, what we can do is just consider we have totally n words, okay, and average length of a word is L. Okay, so what we are doing is for each word, remaining words will be n minus 1, and we are checking whether this is suffix or not. So for the suffix we have to compare each character, so this will be the time complexity in this case, which will be O of n square into L. And space complexity over here is how we can implement it. For example, here we can use set to save this number, or we can directly use two loops and consider it. So for example, if you are not using any extra data structure, just using the loops, and in the loops only we'll check whether it's a suffix or not, so that will take O of 1 extra space, because we are not taking any extra data structure for this. So if you want to optimize it, clearly you can see that we need to find out whether a word is suffix of a other word or not. So next approach would be, let's say approach 2. So what we can do is, instead of using the loops, we can save the words into some data structure, let's say hash set, and then try to remove all those suffixes from it. So what would be the first step? We can create a hash set, and into this I will add all the words we have. So in the given example we have 3 words, which is time, me, and bell. This will be initially present into the hash set, and what we can do is we will traverse each word again, and all these proper suffixes we have, we try to remove it. So for example, the word time, what are the proper suffixes we have? So for time we have one suffix as e, another one is me, another one is the ime. These are the 3 proper suffixes. We'll try to remove it from the hash set. So e is not present, m is present, remove it. Time is not present. Next word is me. So again, what are the proper suffixes? E, no need to remove, there is nothing. Like bell, what are the proper suffixes? L, ll, and ell. So we need not to remove anything. So now finally in our hash set, what are the elements present that we can concatenate and return it. So this will be our answer, and its length will be 10. So in this approach, what would be the time complexity here? So again I'll consider total number of words as n, and average length would be L. So what we are doing is, firstly we add all the elements into the hash set. So if average length is L, so total time to add into the hash set would be O of n into L. The second step, we are trying to find all the suffixes. So how many suffixes for a word will be? Nearly n minus 1 if n is the length. So in this case we are considering L as the average length. So L minus 1 would be the total number of suffixes for each word. How many words we have? N words, right? And for all of them, what we are doing, we are trying to remove it from the hash set, which will take L time again, right? So it will be n into L plus n into L square. So this will be overall, we can say that it would be n of L square. Now comes to the space complexity here. So we are creating a hash set and then trying to add the elements and removing it, and what is the size of hash set would be n into L. So the space complexity would be n into L. Now if you try to improve this further, what we can do is, let's see, the pattern is we have to find the suffix of each word. So the best way to find the suffix is using the try. So we can use try over here. So while creating the try, we can add all the element into the try, and then further we can traverse the try and see and only use the words which are not repeated, which are not the suffix of any other word. So how we can do that? I'll take the same example again, which is time, me and bell. So what we can do is, the first step would be we can add all the element in try. Second step will be traverse the try, and if there is a new word, what does new word means? It's not suffix of any other word, then we can add its length. Okay, so for example here, if you want to create the try, so try will create from the right to left because it's a suffix tree. So here in this case, the try would look like E, then M, then I, then T over here, and then other word is E, M again will be added, and then bell. So B, E, L, and L. This will be the try. Okay. Then how to compute this length? What we can do is we will traverse this try, and whenever we find the end of the word, right, then add its length. For example, here if you traverse, so 1, 2, 3, 4. So here once we reach here, then this is the end because there is nothing, right? Then what would be the length? Length will be, total length is 4, and we have to add hash as well, to 4 plus 1. Similarly, if you traverse this branch, then again it will give 4 plus 1. So total length will be 10. Right? So what is the time and space complexity for this? So let's compute time complexity. So time complexity would be, first step is we are adding all the elements in the try. So in try, in order to add a particular element, what is the time which is taking L, right? Because we are traversing each word and creating new node and add it. Then how many words we have? N, right? So O of NL will be the time, and then again we are traversing this try and getting the length. So this will be the time complexity. And what will be the space complexity? So in this case, in worst case, it might possible that for each word present, for each letter and in each word, we have to create a separate node. So total number of nodes will be n into L. This will be the size of a try. So NL will be the time and NL will be the space over here. Okay, let's jump into the solution and I'll explain how it works. So what I did over here is, I have created one try. Into this, I keep on adding the elements, right? And then I traverse the try and find the length. So I'll explain how I'm adding the element. So let's first tell you what the structure I'm following for the try. In try, I have a array of children, right? In this case, it will be 26 because the problem statement shows that we have only lowercase characters. And then I use two variables, one for the what is the length, another one is what is the number of children. So number of children says that for a particular node, in the last diagram if you see, so here the number of children for E, M, I, everyone would look like to be 1, right? If there is something like a try node, let's say the try would be something like A, and there are two words over here, let's say it will be, it is C. So for this node A, the number of children would be 2. Now what is the length? So length is basically when there is an end of a word, right? For example here the end of word reaches, then we'll have one variable which says the length. So in this case length will be 4, here also length will be 4, right? So why I'm using this variable is, okay, so I'm using this variable because while traversing, otherwise while traversing the try, if you know the length, we need not to have a count while traversing. That's why I'm using the length, and number of children will say that whether I need to go further or not. Otherwise I have to traverse the complete children array to check if all of them are null or not. Just to save that, I use this variable. So what I'm doing in the add method is this one is not required. So I will traverse this word from right to left, and then we find the index. If this is the normal try add method. If the node is not present, we'll create new node and I'll increase the number of children. Right? If node is already present, then I'll just move to that node. Right? And at the end, once all the letters we have added into the try, I'll update its length. Right? Then once all the words are added into the try, now the next step is how I'm computing the minimal reference system. For that, I will traverse this try in DFS fashion, and whenever we reach to a node where there is no where number of children are 0, it means that this is the end of the word, right? So at that point of time we'll return root.length plus 1. 1 is for the hash, because in reference string each word ends with hash symbol, and remaining we just traverse all the 26 children, and if it is present I'll just call again and add it. Okay, thanks for watching. If you have any doubt or queries or suggestion, add it into the comment section.